Hi, everybody. Welcome to Catalyst Cat. This is our episode 1 of our nutritional science podcast series. We are here today with Dr. Simone Bayer to learn. I'm going to butcher your name again and again. Sorry, Simone. Can you pronounce your last name one more time for me?
Bayer.
Oh, it is Bayer. Okay, perfect. Bayer.
It's like the famous company that makes all the
Ooh.
drugs, but sadly not related.
I'm sorry. My audio we just cut out into. Okay.
Ooh,
Can you speak again?
yes.
Awesome. Okay. I don't know
Okay.
why we suddenly cut on my earphones. All right, that's okay. Awesome. Did we say buyer again?
Bayer.
Yes. Okay, buyer. Okay.
Yes.
I don't know why. I feel like the year at the end always gets me a little bit.
Yeah, it's like that German company that makes all the aspirin and stuff. Sadly, we're not related.
Sad you're not really because you're not making money off it too. All right. We're here today with Dr. Simone Bayer to learn about the hierarchy of scientific proof. Hi, Summer Sauce. I see here in our comments we have Summer Sauce here. Hello. Let me quickly share our screen so we can get started with our slides because we got some fun slides going on here. We're going to start with our lecture slides. Let's go. We're gonna pop up. Here we go. This is so exciting. All right. I keep doing share instead of present. Here we go. Hello. Here we go. All right. So starting off, because this is our episode 1, we're going to actually do a little introduction. So, the rules and guidelines for our actual podcast here for everyone. For anyone who are joining in or in our comments or people who join in the future, please be kind, courteous, and respectful to each other and in the chat. Okay, we like to maintain a positive environment, and we would like to encourage you to be curious and innovative because I'm doing my best to bring in these fascinating and really intelligent and really cool scientists to share the really cool things they've done. And this is the place for you to be curious and ask questions and ask all the questions you've always wondered but never dared to ask. That's totally okay. Do it. Go for it. Make those comments. And third one, number 3, be open-minded. And I can't read that because it's under my camera. Be open-minded and compassionate towards yourself and others. It's okay to ask questions. It's okay to wonder things, but be mindful. Not all of us might have the same education or background, and something that might be very true to you or very evident to you might not be evident to everyone else. So please be mindful of these questions. And if you can help answer questions, feel free to do it as well. But let's not belittle each other, and be compassionate to everyone. And then 4th, feel free to comment questions for the speaker. We will do our best to answer them. We have this ability to actually, put these comments here. Like, oh, hi, we can pop them onto our screen so that we can highlight any questions and answer them as we go. And the 5th one, if you're not watching this live, you can still comment below. We can always answer them via text or like in the comments or in our future episodes. For one, we have Simone here for 3 episodes. I'm really excited to be able to keep asking her all these exciting questions in the future. So let's get going. So, introduction to our speakers today. Hello, everyone. I'm your host, Kat, aka the Catalyst Cat, and I'm on a mission here to recruit innovative and curious scientists around the world to share their knowledge and findings with everyone. Okay, we are here with everyone here on YouTube and via my nutritional science podcast series. So with me, I have the honor of hosting Dr. Simone Bayer. Unfortunately, not the pharmaceutical, but she's a research fellow at the University of Otago with a master's in nutrition science and a PhD in pathology. Simone is highly interested in the complex field of functional gastrointestinal disorders. Oh my God, what a big words. We'll find out more about that. And especially irritable bowel syndrome, IBS, what's most commonly known as, and as well as functional constipation. I did not really even know what that was really before I met her, and functional diarrhea. A lot of fascinating topics that we would love to dig into one day. And here, Dr. Bayer, would you be able to? I can't English. Why don't you give us an intro about yourself as well?
Hi, I'm Simone. I'm currently living in New Zealand. However, I come from Germany, and so I'm all over the show. So nutrition science from Germany, pathology here in New Zealand, and I'm currently doing clinical trials. So meaning that I know my way around the lab as well as around people, and especially around the gastrointestinal tract, and which basically brings me to the main questions. We want to know how food affects digestion and for me, it's especially how food affects this disordered digestion. So when digestion stops working, that's pretty much me.
She's being humble, very humble. It's okay. We can dig in more. She has cute pictures of dogs and her fun stuff she does. Lots of cute pictures. We'll get into her more. Well, thank you for that wonderful little intro, Dr. Beyer. If you have more fun facts or anything about your research you'd like to share on in the future, please feel free. And then we will also link in our corresponding blog a link to Dr. Beyer's research as well as her current position and a little blog post about what we've talked about today. So I'm excited. So before we jump into the hierarchy or our topic today of hierarchy of scientific proof, let's chat. Let's chat about really why scientific proof is even important. Why are we even talking about this? Like, why are we starting off with this scientific background and research instead of going straight into her research on kiwi fruits and constipation? So let's talk. Why is it important? Dr. Beyer, can you tell me, why are we talking about this? Why is scientific proof important?
Because we only can know when it works, right? And one of the things, for example, there is no such thing as proof. There's evidence, because techniques and people and experiences change. I mean, thousands of years ago, there was thunderstorm and there was lightning, and people didn't know what it actually is because they had no understanding of electricity. And so they're like, oh, it's the gods, it's empty. So for them, the scientific proof back then was the gods must be angry because the proof was there was a lightning storm and it basically burned my house down. So they must be angry with me. However, we come a long way since then. And so we changed it a bit. And the thing is that what we know, for example, just 50 years ago might not be true anymore because we've come a new way. So we have more evidence, because that's why it's called the scientific discourse. We disagree on a lot of things. However, especially in recent time, especially because of news,
Fake news.
not fake news, just the way news works. They like to be balanced, but what they don't understand is that the way they report it is imbalanced, because they instead of asking, showing like 90% of scientists agree on this, and so the burden of proof is quite higher, and they put that alongside someone, just one person with no scientific background, that pretty much says, no, the sky is yellow. That is not balanced.
Yeah.
And so so scientific proof and the knowledge that there is actually no such thing as proof, because there's no bottom line usually. We get to know things change, human biology changes. So even if our knowledge is quite stable and we haven't added much to it, it doesn't mean that we might find this one human that is so completely different than anyone that it's not true anymore for this person.
There's just so much for us to discover. There's so much for us to discover. Yeah. And unfortunately, like you said, it's not always balanced. And I think that's why I'm trying to get scientists like yourself to come on here and talk about your research, because oftentimes, you're doing clinical trials, and we might all do them. Scientists might do them for different reasons or incentives, and that is normal, right? We all have different things that interest us, etc. So it's kind of important for us to share the information openly. I think that's why there's such a drive towards open source or open access information and knowledge, and so that we can truly balance it out, so that it's not just maybe, I don't want to throw shade at people, but we don't want to we don't want the knowledge out there to be only what is most advantageous to a certain group of individuals, but instead presenting the information like that is peer reviewed. We'll talk about what peer review means. Sharing that information with everyone so that we're able to make informed decisions, and not just informed decisions based on narratives that is, benefiting, any pharmaceutical company, etc. Right? I totally agree. I agree. I had a slide here about fake news, and and it's not necessarily about fake news, but it's about like when we are presented with data, with information, how do we assess it, and what does it mean, and how do we, do we believe everything we see? Honestly, nowadays, Dr. Bayer, like when I see all of the AI research coming out, and you can make videos of people doing things, it's scary. It's honestly kind of scary, and it's kind of scary. So you can't just believe what we see anymore, and that's why in science we have something like peer review, and we have journals that have very strict requirements, etc., to actually maintain the integrity of our research, right? So things to think about. These are the thoughts that keep me up at night, Dr. Blair. These are the thoughts that keep me up at night.
Yeah, the good thing is that usually with peer review, it might take a while. And especially, as I said, scientists disagree all the time. And sometimes if a scientist lies in their paper, it takes some time for us to find it because others basically have to test it.
Yeah. Didn't
so
that happen?
Yes.
With,
There was this, I think that was the guy that...
with HIV? Was it?
No, not I don't think it was HIV. Back in, I think it was in the 80s or 90s, there was this scientist that cloned a sheep. And so the first cloned sheep, Dolly. And he did that. However, he did some of the information that he wrote in that paper was, I think, not true, and he's now pretty much vanished. I don't know. Or, for example, the other thing is pretty much, which a lot of here is about a very hot topic. So I'm really sorry that I have to mention it.
It's okay.
Because that's another thing, that misrepresentation of data, be it by the news media themselves, because only the cool thing is newsworthy, the new, the exciting. And a lot of people say, for example, scientists tested food coloring for their effect on mental health in children. And so they tested all the colors, blue, green, yellow, whatever. And there was no statistical significant anything. However, in that whole paper, they said, oh, well, there has all these tables of food colors and the effects. And they're like, if you really squeeze your eyes really hard.
Squeeze my eyes really hard.
Red food coloring may have a very tiny effect and might make children fidgety. And then the newspaper is like reading this paper, and they're like, yeah, okay, food coloring doesn't do anything. That's boring. And they're like, oh, but the red does something. And so the news headline will be, red food coloring makes your kids fidgety. It's just pretty much a misrepresentation. The other thing that might happen is pretty much when the scientist has bias. We're all biased. And if the scientist pretty much goes the not so clean pathway, and I have to now go into the really discussion-worthy things and vaccinations. Our favorite person, Dr. Andrew Wakefield, and his
That's
study.
The autism one. That's Yes, I remember Dr. Wakefield. Yes,
because when you're looking for a certain outcome, you can basically fudge your study group a bit. So if you, for example, just take the general population as your study people, which he should have done, just kids, specific age, vaccination, and look for the outcome, then his study would be great. However, he actually picked the children from a clinic that had mental health issues. So a specific clinic for kids with mental health issues. Of course, there is a high likelihood that you pick autistic kids, right?
His population sample, yeah. That's cherry picking.
And even worse, I think he also basically invited kids from his son's birthday party to take part in the study. So we get into dodgy areas about consent. And then we have to also have a reason why we always state our disclosures. So basically, do we have an invested interest, incentive in it? Because he was working on a novel vaccination against measles, but it was just a single vaccination. And so what he wanted to do is pretty much discredit the combination product. So that is another thing. However, you
Whoa.
only find out these things if you read very, very carefully. So you basically look, okay, is the method right? What are the disclosures? What is the population?
I didn't know that about his conflict of interest and him disproving that vaccine because he had other interests. That, oh my lord.
And it has been now an ongoing thing. And I'm sure my inbox will explode. And he might even go after me. I hope not, but
No. Jeez.
yeah.
Well,
So
no, this
just if
is
you
open speech.
even if you read a scientific paper, you have to basically really check.
Mm-hmm. I agree. We have to be mindful. But, well, that's what we're here for today. We're here to, it's hard to check, and not everyone
Mhm.
has the time to check, but we're going to go over some key terms and studies so that all of us can really approach information with a more, just more knowledge, really, so that we can, when you read clickbaity titles, you'll kind of be able to go like, okay, well, what did you actually read? Or are they writing the entire article based on like, what's it called, one very biased article? Like, is that what it's based on, right? Or it's like, I've seen papers that's like it's a paper talking about the benefits of soybeans, and then it's just like this beautiful paper with no negative impacts of soybeans or anything. And I was like, wow, it's very shocking to see a paper that doesn't provide any opposition or any opposing views. And then I checked the authors and their conflicting interests, and it's released by people that literally work for like the soybean associations. And I'm like, well, that makes sense, But I'm getting completely off topic. But yes, I completely agree. So that's why we're here today. This is gonna be a fun time. Let's kind of jump into, what does it mean then? So then now that we've established, why is it important to understand like scientific proof? Let's kind of go into, how can we disseminate this information and like learn. So let's kind of hop on into the evidence hierarchy, and really, what is the best evidence? Here we have a little a pyramid of the different types of evidence or different types of studies that we will be going into. And this is kind of, it's okay, y'all, this is this is not your Maslow's hierarchy of needs, or it's not like it's not the food pyramid here. So here we're kind of disseminating the different types of information and the power of the information. Like, as we go higher in this hierarchy, it's kind of describing the amount of details, or not details, the amount of evidence behind them, and the peer review and the power of the evidence behind them. And so this is kind of what an outline we'll be going over. And I actually see a little comment here. I think that's a question. Dr. Byer, if you don't mind, let's answer this quickly. It says, not quickly, take your time, but asks, are there integrated ways that protect the public from bias and incentivize paper like this? And I can't help but think pharma companies would take advantage of people and lie about their drugs. This is actually a great question, and a very conflicting question. It's very controversial.
So sadly, freedom of speech is protected in most countries. So you can pretty much say whatever you want. However, as I mentioned, try to, if you find an article or a blog entry, go and find the original paper, because as I mentioned, these things are on the paper, in the back, in the information. For example, I worked a lot for a specific fruit company. And they paid me to do the work. However, I'm always upfront and saying I'm not directly. So my salary is paid by the university. It's just pretty much that they basically gave me the product or asked me to provide information, and so that way I can be unbiased because I'm not pressured. However, then the other thing is, if something is disadvantageous for a big company like a pharma company, they might not be that happy to publish things that are not that great. so you will never hear about it. So
So
sadly,
yeah,
it's a bit
so
of a
good. It's a
so
toss
sadly
up.
there
Yeah.
it's a toss up. It's hard work, especially for the individual, and sadly there are no ways to prevent that.
Yeah. I agree. Unfortunately, I think that's kind of always goes back to what we're talking about. We can't stop the dissemination of information to everyone. And unfortunately, we have freedom of speech. Therefore, what we can do, and that's what we're doing here with this podcast, is then sharing information in a way that teaches everyone to make informed decisions so that, you're not just reliant. Yes?
I just and I remembered something. One of the things, especially for drug companies and pharma companies, if they test the drugs on human people, like clinical trials, um, there is something called the clinical trial registry, and this is public information. You can Google it. You can see any clinical trial on any medication that you want to look at, for any disease that you want to look at, if they're active, recruiting or not, or if they're finished, and the summary report. So that is a way to
Oh.
circumvent that a bit.
Are they required to share those findings, even
Yes,
if they're negative, etc.?
yes,
Oh, wait. Okay, we're totally going to
because
plug this
because this is part of the
clinical
ethics.
trials.
We have to all adhere to ethical rules.
Wow. So this is the clinical trials that Dr. Bayer just mentioned. Is it clinicaltrials.gov? Because this is with the
It's
NIH.
different. It's different for
Every
example,
country.
I would pretty much register my clinical trials for the Australian New Zealand clinical trial registry.
Mm-hmm.
But yes, and there's also an international clinical trial registry, I think, for universal number that will link with each of the different countries.
Wow. I did not know this was a thing. We'll plug this in our descriptions later, but check it out. Okay, I'm really tempted to test one. Here, we'll just test one. Let's test one. So, for example, off the top of my head, I have narcolepsy. We're gonna test narcolepsy. What are studies with Whoa. Oh wow. So you could see all the different types of studies being run, completed, etc. Wow. And they're recruiting. Wow. Wait, so they're not required to share their results, or are they?
Um, we get pretty much it's actually in the rules that you need to basically
Mm-hmm. Disclose it.
publish it. You should publish it, at least a summary of findings.
Wow.
However, all you basically get is nudges. But the bigger you are, the more rules you have to adhere.
To
So
comply. Mm-hmm.
yeah, about
That makes
compliance
sense.
and things. So I remember when I started my clinical trial and it took longer because of the pandemic, I got regular nudges and emails saying, "Can you please update? Can you please update?"
Wow, that's what we love. I think we love that though. As scientists, there's so much to keep track of. I'm glad they send us reminders like that. All right, before we get distracted again, Dr. Bayer, you'll find out I get very distracted looking at cool things with you.
Hey, it's fine. I'm the same. That's why I'm a scientist.
Exactly. We find all these little rabbit holes and we just go in, we jump in, and we're like, we gotta get to the bottom of this. It's dangerous. It's dangerous. All right, everyone, let's kind of go back to our evidence tree here, or evidence pyramid, and we can start from the bottom. Background information, expert opinion. Whoa, why are we talking about background information? Shouldn't that be like the top? Not in science. Not in science. In science, these expert opinions is actually at the bottom. So take it away, Dr. Bayer.
Yeah, so background information or expert opinion is pretty much discussion worthy. It's the stuff that you read it on Wikipedia, something new coming up
Mhm.
might be a new patent and nobody has really tested it before. Or it's your neighbor that says, "Oh, I made a batch of kombucha and it really cleared up my skin." And you're like, "That's really nice." But we don't say that's data, that's anecdata. It's, it's anecdotal experience. It's a background info. It's like kombucha and this person feels that it cleared their skin. Awesome.
Mhm.
So the next level then would be a case report because they basically go with that information to their doctor. And the doctor is like, "Oh, this is cool. I've never seen that before." And so they basically make a case study or case series even, basically saying, "Okay, I have this one patient had bad acne and he drank this kombucha and it completely cleared the skin in a few weeks. And funny enough, actually, half a year later, their neighbor came and they had also acne and they also had, after drinking the same batch of kombucha, had their clean skin." And suddenly you have a case series. It's a similar issue, similar observations.
Mhm.
However, it's just a handful of anecdota.
Mhm.
So it's pretty much it's a medical person that says, "Okay, I saw this happening. Did someone else see that happen?"
Mhm.
So the next level would be an observational study or a cohort study. That would be pretty much a scientist asking half of the country or just the people in their town, "Have you had better skin after drinking kombucha?" You know,
These questions.
I know I just picked it out of my nose. It's
I
not
love
really
it. It's
real.
perfect. It's perfect. It's relatable. I
But
get it.
exactly, so it's a cohort study. And then they basically say, "Okay, 15% of the population actually had acne, and 10% of those were able to drink kombucha, and of those, 5% had less pimples." Awesome. That's a cohort study. However, um, then now goes into the randomized control trial, which is important because then you basically say, "Okay, I'm going to recruit, let's say, 100 people with pimples, and half of them, I give them kombucha, and the other half of them will just drink normal tea. And we will measure or count the pimples in their face over a specific time period. And then we can see if they actually reduced or not." But now we also go into why case or controlled trials are a little bit tricky for food, because it's food. Everybody has to eat. Usually you would basically, if you have a medication, you would give a placebo. It basically looks like a pill, but you don't know what's in there. If most of the time it's sugar. However, with food, there is no food that basically looks and tastes like food, but is not food.
That's a
Yeah,
difficult thing to control for.
exactly. If I do my kiwi fruit study and say give the person a kiwi fruit and say, "Eat this," and by the way, this is not a kiwi fruit, they will look at me funny. And so, especially in the nutrition area,
Mhm.
other medical trials look a bit funny at us because we're not blinded,
Yeah, it's much harder to
because
find.
it's harder to blind. And so the placebo effect or the nocebo effect is much more pronounced because we know what it is. Or the patient has a bias again because they hope it
Mhm.
works. However, it's still another level because someone actually went to look at it. So if now a lot of people would make these things with kombucha, so there's a study, for example, in Japan, and they have green tea kombucha, and there's a study in Germany, and they have black tea kombucha, and there's another study. Someone can actually then do write an article on it and do a review of it, and they basically then think, okay, how could this work? What could be in kombucha that actually affects skin health, and have their opinion on it or not. So it's pretty much, we would say that qualitative, not quantitative, but qualitative reviews.
Mhm.
Um, and they could be written either by people that know a lot about tea or people that know a lot about acne. However, again, it's not really filtered. And
Mhm.
then the last level is pretty much then we go into top the critical appraised topic and a systematic reviews. It's pretty much the person that actually might or might not have any idea about the underlying issues, but they take all the studies on kombucha and skin health and put all the number of participants, pimple size, pimple form, pimple numbers, timings, and put that into a mathematical statistical model and analyze it, which is then a systematic review. And that is the highest level because it's not just one person saying, hey, I drank kombucha, but it's literally millions of people that had maybe a positive or negative effect. And if you pretty much then compare that really well, you can have a meta-analysis, and usually is the way it is no effect is 1. That's how they mathematically say it. No effect is 1, and if it's or 0, and if it's a positive effect, it goes in one direction, or if it's a negative effect, and it goes into the other direction. And so the meta-analysis could say, okay, we have analyzed all the studies available. This doesn't do anything. Or it could be, yes, kombucha definitely reduces pimples. So skin doctors might actually prescribe kombucha in the future. Or it could say, well, actually, you get double the pimples. So don't. And that is pretty much what a meta-analysis can affect. And that is highest level. But again, only if it's a good journal, because that is where the peer review comes in. Because a good journal basically has something called peer review, meaning they send the article that the person has written, no matter at what level, and send that to other scientists and ask, hey, can you read that? And can you tell us, is everything right? And so the job of the peer reviewer is to look at it, might not even be in the same field, to look at it and say, okay, is the background information the right one? Is the treatment the right one for the disease? Or is this in this time, did they actually test kombucha, or did they test orange juice? Was it tested on people with acne, or people with pimples, or on people that have no pimples at all? So they check that, and then they can say, okay, this person has done a lot of good work. However, the statistical analysis is rubbish. Please tell the author that he needs to fix his stats. That might happen.
Yeah. So I'm just going to say that has happened. That happened a lot in my previous research. Everyone's research.
And everybody's research. And sometimes it's pretty much the saying, oh, okay, you do the clinical trials, but your clinical trial is on 12 people. Maybe you come again to us when you did that for 200 people. Happened to me before as well.
Yeah.
Or they're like, okay, that's really great, but you didn't even, you basically say that kombucha is good for your skin. However, you didn't even count the pimples. You just took a picture. That's nice, but
you just didn't count the pimples.
It's literally, you use a method which is completely wrong for what you're actually trying to say.
Yeah.
Or they say, and then it's not published because it basically goes back to the drawing board. Or they say, that's really cool, but have you tested this other method? Have you actually compared the kombucha with vitamin A cream, which is a proven scientific method to reduce acne?
Yeah.
And have you checked if it works better or less? These things, and that is why it's important. And because there are journals out there that if we publish a paper, we as a scientist have to pay the journal for publishing. And there's a lot of papers that don't even do peer review because they just are interested in their money. So they will publish everything.
And
nobody
checks
checks
published. Yeah.
Exactly.
Yeah.
And so the way we scientists are usually discussing the quality of the journal that publishes is something called the impact factor, or IF. And so the higher the impact factor, the better or more complicated and longer the peer review.
Mm-hmm.
So that's another thing, how to find out the good papers from the bad papers.
That's how I started sorting for nutrition journals. I was searching for the nutrition journals. I sorted from the ones with the highest impact factor first. That's how I found Dr. Bayer here, actually. So, wow.
Just a funny side effect. One of my favorite papers that actually exists, and it is called "Take Me Off Your Effin' Mail List." So basically, what happened is a predatory journal contacted a scientist and contacted them again and again and again and again to pretty much help publish a paper with them. And so he wrote this one sentence a few times.
Isn't this Stanford?
Yeah.
What?
It's a published paper. And it's dedication. And you can see he even make pictures. And that happens pretty much if you annoy a scientist too much.
What the heck?
So this journal that published this paper is definitely not good.
This was actually published?
This is published. It's a published journal. It's not a good journal.
Wow, predatory publishing. So the journal is predatory. It's not real. They just accept anything. This is so funny. Then look at this. This paper was rated as excellent, but acceptance email. What? Wait. Oh my god. And all it took was $150. Okay, so I should submit. That's ridiculous.
Yeah.
Wow. It was accepted. That the International Journal of Advanced Computer Technology.
So one of the
shut
things,
down.
Yeah. So one of the things that if I get asked to publish a paper with a journal, I first basically check if they're a real journal or not.
If they're real, yeah.
Or if I find a study that pretty much says exact opposite than what I found, I also check. If it was published in a good quality journal or not. So yeah.
That makes sense. Yeah, Dr. Bayer is very what's the word? Very on top of it. When I first contacted her,
you have to.
She responded to my email saying she stalked me on LinkedIn to make sure I was a real person. Like, yes, Dr. Bayer. You have to be careful because you're as scientists, especially as scientists, when you're in media coverage, etc., it's just about getting that clicks and getting that marketing, getting everything. But as scientists, you're attaching your name and research and integrity to whatever research you put out there. So it really matters. But now they have their names on this paper. I love it. This just made my day. This just made UCLA and NYU. This is hilarious. I can't believe this is published. Oh my god. Oh God, this is great. Thank you so much for sharing this. Did they put it? Oh, we have some questions here. If the author, do we know if the author put that on his resume?
I don't know.
Oh God.
I know of a different author who insisted to put this cat name as a co-author, and I'm really sure that
it worked.
Oh, he insisted. He literally insisted. He was like, I think I found that recently. And I think so. I don't know that author, of course. However, being so insistent, I'm sure his cat also had a CB. Sure.
I need to get a CB for my pets now. Man, that's the thing. That is one thing I'm noticing a lot more. Those of us in academia or something, you're very careful about the things you say and the things you do because it's the integrity of the work is very important. And it's very different than people just saying things on the internet, right? As scientists, you don't You don't do that. You don't claim to have knowledge on things you know you don't, because you have to be very mindful and you have to know the validity behind your arguments, etc. You wouldn't just say things without having something to back it up. And so, gotta keep that in mind. Okay, I know I'm getting really off topic with our lovely article of Get Me Off Your Mailing List, but let's kind of hop back a little back here. So we were talking about that because we mentioned the validity of journals and whether they're good or not, and that's where we were in terms of filtered information. We're going to skip some slides here because we basically went through a lot of things with filtered and unfiltered information. I'll do a quick little picture here. So here, for those of us who aren't familiar with really what does filter even mean, I thought about it in terms like, coffee grounds, or literally you put your coffee grounds. That's all information out there. Just, I think it was like cohort studies or just anecdotal information. That's unfiltered. It hasn't been aggregated and controlled or really reviewed, really. And after we put it through the process of putting it into journal articles that will assess, okay, well, will I accept you into my article? Then that's kind of our filtered information. So unfiltered is all your BuzzFeed articles and all the stuff we see everywhere on the internet. All the information, all the blog posts people shoot out. Now that you have OpenAI, you can write a blog post super quickly. And is it actually valid information? We don't know, right? But then, we put it through the very tedious process of the scientific process. And then the things that come out, the delicious coffee, is the filtered information. That's kind of a very easy way to think about it. So, or those of you who, I'm trying to think of how can I make this analogy for maybe kids or other people who aren't in academia. I think the coffee is a good one. Dr. Byer, would you have any other kid-friendly analogies for what is filtered or unfiltered information?
The only one that came out in my mind is pretty much when it comes to the different colors within light, which is a bit hard to understand. White light consists of all the colors of the rainbow, but you only see it as white. But if you have specific glasses on, everything turns in the same color because you filter all the other colors out.
Yeah.
If you have pink glasses, that's why we also say, you look at a person with rose tinted glasses or pink tinted glasses and everything looks lovely and pink when you're in love.
I like my filtered glasses. I'm gonna try and go a little bit even more simpler.
Not cool. Not too complicated.
It's a little complicated. Dr. Byer, I did not fully understand light until I was in university. It wasn't until university that I even learned
complicated.
How yeah, let me think if we have any, or if any of our courageous commenters or people here. Another filter example.
Oh, maybe kids' ears. Kids' ears are really good filters. Because kids tend to hear only specific things. They will hear the mom yells, "Clean your room." That will not go through the filter. They won't hear that. But if you basically scream in the same location, you would scream, "Hey, there's ice cream left." That goes through the filter.
Through. That is the filtered information. That's the important information that is filtered through.
Exactly.
I love that. That's a great one right there. Unfiltered is all of the information that we're taught throughout life. All the information thrown at us. And the filtered is the ones we choose to listen to. Not the ones about clean your room, not about the ones to do your chores. It's the ones at the very end about, it's Christmas. Come downstairs for your Christmas present. Or, it's your birthday. It's all the good things we choose to hear. That's the filter. There you go. That's a great one right there. We have a comment here. As a kid, I played in the sandbox with those sand sieves. Oh, so I can pull out the toys from the sand. There we go. Okay, sand sieves. I can pull out the toys, and the toys are what we're trying to obtain from the knowing sand. Yes, in a sense,
that's a really clever way to clean up. That's amazing.
Clever way to clean up. We only want, so basically the scientific process, or the process that we are explaining today, is the sand sieve itself. We're talking about the different steps that scientists in academia really have to go through in order to give you that toy in the end, so that we are actually holding onto these nuggets of knowledge instead of all like the sand and all the other information that comes through that's not actually important. There you go. That's a great analogy. Thank you. Clearly, the two of us are good. Our analogies are great too. But thank you. The Sand Sieve and toys is really great. It's like golden nuggets. Oh, it's like a gold mine or whatever that is. Back, what is it? The gold rush days where they, you shake it and you try to get the gold out. I'm getting distracted again, Dr. Bayer. Let's go. Next slide. So we got filtered and unfiltered information, and then from there. Unfiltered, we talked about the randomized controlled trials, cohort studies. Dr. Bayer, our cohort studies, are they not peer reviewed before they're published?
They are peer reviewed. However, it's still an observational.
It's still an observational study. Still okay. You know what? I think we have a slide on that.
Because it's pretty much if you have one person that is biased, and we are all biased. As scientists are biased. Biased meaning you have a preformed opinion. We try not to, but sometimes we really see what we want to see, even us. And even in the peer review, this can go through.
Oh no!
And so it's still unfiltered. Kind of. It is, if the method is valid, but it still could also be true if it's for example, in the diet realm, different communities have different food, and so whatever is observed in a cohort study or in a randomized trial can also only be true for that community. So it's also very specific, and only might be only applicable to that group.
That makes sense.
And so it's pretty much once we have the level from different cultures, and so we can generalize it for everybody.
That makes sense. And that's why we would then go from observational studies to then experimental studies. That makes sense. We will get there. For those of you who don't know what that is, don't worry, we got you. And then, we had a picture, filtration. Oh yeah, like air conditioning particles. Okay, I'm silly. Okay, so we keep using these observational versus experimental studies. Dr. Bayer, can you kind of give us, you and your big wrinkly brain, give us insight as to really what is the difference between observational studies, experimental studies?
So observational is pretty much without input from the scientist. The scientist will give questionnaires and might collect some samples, but he will not change anything. For example, so you basically, when we go back to the kids playing, you have a child playing in a playground. We will just sit there on the bench and watch.
It's not creepy.
It is.
We're just observing.
Psychologists do that a lot. I mean, there's this one guy who pretty much likes to go into supermarkets and just counts the number of people that grab bread with the tongs and the ones that do not use tongs. It's observational. He just stands there and looks and counts his numbers, or you look out the window and count the red cars that pass by. It's observational. You haven't changed anything. But as soon as you basically say you alter something, you change it, then it becomes experimental. Because you're doing an experiment, you were like, I wonder if the tongs would be red if people would grab them more. And then you do an experiment because you change the metal colored tongs to red tongs. Or you're like, okay, I wonder if we give the people information about their diet, if they change their diet accordingly. Again, that's an experimental study because you do an experiment. You're changing the system.
We're making the changes.
So and usually the less you change at the same time, the easier it is to observe. So, for example, you're changing just the behavior, or you're changing one ingredient in a food, or you're testing one pill, right? You're not changing all of it at the same time. because pretty much, for example, if you test a migraine medication, you want to know the outcome of the migraine medication. You don't want to give at the same time meditation support, because you cannot say that if it was the medication that worked or if it was the meditation that worked. So, but yeah, that's another thing.
Yeah.
Experimental and study design. Make sure you actually are able to observe what you want to observe.
That's a whole nother lecture. That's a whole nother lecture.
Yeah,
Experimental design.
Experimental is pretty much you change one thing. For example, we as humans in our home, we play scientists a lot. We do experiments a lot. It's just how we say n equals 1.
That means our sample size.
Our sample size, n is the sample size, so our sample sizes might be just 1. But you're like, okay, I have cold feet all the time. I wonder if it's the cotton socks. Maybe I'll buy a pair of woolly socks and see if that changes anything.
Yeah.
And so that's an experimental study, even if the sample size is very small.
You know, Dr. Simone, well, it doesn't have to be small, because those of you who know me, you know, that's why I get a bunch of different socks, because I have to have a larger sample size to make sure that I'm wearing the best, warmest socks.
But you were not wearing them at the same time.
Oh, no, you're right. I can't really assess. I can't control. It's not a control, because I'm not wearing them at the same time, and the temperature outside might be different on different days that I wear them. So how can I adequately compare if one is better than the other? Okay, that's sample design. That is sample design.
That is
experimental design. Yeah. Wow. Okay. Let me try and sum this up in like a more friendly manner. So then, observational is, for example, if we were to say, I'm trying to think like how to make this kid friendly. Like observation is saying, okay, if we're in school and okay, well, pretend we're teachers. Our observation is that, wow, all these kids are late. Or you can say, okay, I notice every day as I sit here, I'm going to notice that these 5 students are late every day. That's my observation. Every day we sit and take note of who is late, how often are they late. Experimental design or experimental study would be, you know, if I were to start giving out incentives or punishments for being early or late, does that number of percentage of students who are late change? Right. So as a teacher, if I show up here, for example, if class still starts at 8 a.m., but if I have a movie playing or if I have a cartoon playing in the morning until 8 a.m., will my students show up early to watch that show? Or like, will less students be tardy because there's something to watch, right? Or that would be like a reward or something. Or like if we were to punish them for being late. So those would be 2 different things to test. But then that would be experimental, because we are adding in different variables to check if, you know, the number of students who are late changes. So that would be our experimental study. Wow, that's really cool to think about. And now, okay, I was really excited to have an excuse to go get more socks, Dr. Bayer, but now I can't get more socks. You're absolutely right. All of us, there are scientists in all of us, and I highly encourage you to run some silly experiments and let us know how they go. Well, I mean, think about it. You know, that's why I eat a lot of cheese. I want to try different cheeses and see which one's better, but you can't adequately control because you're not eating the same day. And my body, if you really want to get into the scientific stuff of it, my body might not be feeling the same way. My microbiome might be a little different this week compared to last week. So my body might react a little bit differently. So, or my palate might be different because of food we're eating.
It's pretty much, if you can't find out if you like Gouda if you have the Gouda together with 5 different cheeses on your bread.
That's true. You need to be able to. Is that how I always pronounce it? Gouda. Is it pronounced Gouda?
Oh, sorry, German pronunciation. It could very well be that it's just me, because pronunciation changes.
No. Oh my God, have I been pronouncing it wrong my whole life? It's pronounced Gouda?
No, I don't know. I'm not Dutch.
Oh, I'm going to Google. We're going to have to look that up in a bit. Wow. Okay, well, now Dr. Byers is not letting me eat all the cheeses I want because I won't be able to tell. Well,
or you can have all the cheeses, just if you make a grilled cheese and don't have them all at the same time.
So I'll make so what? If in order to test them individually, we'll have to make 5 separate grilled cheeses with 5 separate cheeses and consume them closely to each other.
Yeah.
so that they're in very similar environmental conditions, right? You don't want to test them too far apart, and you'll have a palate cleanser in between.
Yes.
It
Now
has
you're
to be
getting
small
experimental
size.
design. Yes.
Okay, there we go. I'm getting experimental
got it.
design. I'm very excited for this.
It's one of the best designs ever, I think.
Testing cheese. All right, let's go. Thanks for helping me understand this a little bit better. Let's go. Let's move on. So we talked about experimental versus observational study. So then, the ones that you don't touch as scientists will then be observational. So then, as we move on to these critically appraised topics, individual articles, and systematic reviews, because our scientists aren't actually interacting with the subjects, then that would be technically it's not even a study anymore, right? Systematic reviews aren't considered studies. They're reviews of studies. And that's why they're so powerful. Exactly. Because then you're not cherry picking anymore. You're comparing all the informations something like systematic reviews. When I see they contain like 20 to 30 even more studies. They'll literally look up all the different papers that have been published that contain different medications or patient populations or whatever genes they're testing. And they put it all into one paper, and that's why it's so powerful. Yeah, so you're grabbing all the information everyone else has put. That's the fun part. Okay, I'm so excited for next week. So our important takeaways from today. Oh my gosh, are we almost at the end? We are almost at the end. I'm so excited. But important takeaways for today. Really, it's for everyone to be mindful. And my words are blocking my camera. My camera's blocking my words again. I can't see it. But be mindful.
To read it?
Yeah, go for it, Dr. Byer.
So
be
mindful of people who claim scientific facts without, I said, proof, because it's more evidence, and bad newspaper writings because they cherry pick, bloggers that, especially if they want to sell you supplements, because the scientists usually don't have something to sell you. And also think critically of where each study currently sits in the pyramid of evidence. Because it's pretty much if they have recent years, but what I mean here is pretty much if you go back to the current pandemic, the vaccine trials were quite rushed. However, the only reason why they could, what they did was pretty much they climbed all the stairs of the pyramid to the top. In a very short time, because the whole world threw money at them. So a lot of things could be done at the same time. Usually it takes more time because you have to make one study, and then you ask for more money, and then you publish another study, and then you ask for more money, and it takes a long time. And so these vaccines came out quite fast. However, it was all happened at the same time. Versus, for example, then people taking different medications and trying that out. But it was pretty much from a case report. They're like, okay, I wonder if this would work. But that was not, the numbers were low. It was just observed. And they were selling their supplements or medication and tried to get a boost out of it. And which was then sadly, 3 years later, we have systematic reviews about these medications that basically said, no, it didn't work. And so it's really important before you basically hurt yourself or hurt your health, to critically think, okay, why have they put that out? What are they trying to do? And where is the study currently? Is it already up there and it says vaccines work, or is it down there and said drink bleach?
Drink bleach. It makes your skin whiter. Yeah, I could totally see that being a thing. Oh Lord.
Because
All right.
it's not what it works. So please don't never drink bleach. It's okay to drink chlorinated water, but it's a different thing.
Mhm. Thanks for that reminder, Dr. Bayer. I completely agree. We'll go through our last slides and we'll end this broadcast. Thank you, everyone, for tuning in. A sneak peek into our systematic reviews, everyone. In the future, we'll be talking about two types of reviews in academia: systematic and narrative reviews. And we're going to talk about this because next week we have episode 2 with Dr. Bayer again, where we're going to be talking about the current landscape in kiwi fruit research. And that's where her research, all her expertise is coming in. I'm really excited. Tune in next week. I believe it's also at 12:30 at Tuesday. We will be posting it and sharing on social media, etc. And if you have any questions, if you are a nerd like me, tune in. And the actual topic and paper is the effect of kiwi fruit on upper GI symptoms, a systematic scoping review. You know what, Dr. Bayer, would you mind if we actually posted the paper? Because I know not everyone, I'm pretty sure that one's open access. I can go and check.
It's open access.
It's open access. I will link it in the video. So if anyone who is a giant nerd like me, we can read it and check it out. And then tune in next week for that paper. And thank you so much, everybody, for tuning in for episode 1. I had so much fun, Dr. Bayer. I hope you enjoyed it as well. Do you have anything last words to say before we tune out today?
Again, I'm not a medical doctor, so any recommendations I did don't. And
so it's safe to drink bleach?
No, please don't. Please don't. No. That's what I meant. Don't do this at home. And I apologize if any of the topics that I mentioned might have offended.
Freedom of speech. It's okay. We're keeping Physics. It sort of PG. We're trying. Yes.
Physics are very offensive.
Physics light. Oh yes, that was really offensive. Filtration of light. Dr. Bayer, how dare you? How dare you bring up physics?
So thank you for having me.
Thank you, everyone, for tuning in. I'll see you guys next week. Thanks, everybody.